in the nervous system. There are 5 major divisions to the brain. The brainstem is at the base and consists of the medulla oblongata, the pons, and the midbrain. Just above the midbrain sits the diencephalon, composed of the thalamus, hypothalamus, and pineal gland. The entire area above the brainstem and diencephalon is the cerebrum. Around the outside of the cerebrum is the cerebral cortex made of gray matter. The cerebellum is located posterior to the brainstem. The CSF, or cerebral spinal fluid, is a clear, transparent fluid with a slight straw color that bathes the CNS. When you would look at cerebral spinal fluid, if you just hold it up in the middle of a room, it will appear clear. You can only see the slight hint of color when it's held in front of a white piece of paper, unless it is infected. The blood-brain barrier is a protective lipid-soluble barrier. It normally allows some substances to pass, such as oxygen, carbon dioxide, ethanol, and most anesthesias. It can be damaged by trauma, which may allow substances you don't want to pass through. The ventricles are the cavities in the brain. The first and second ventricles are located in the right and left hemispheres. The third ventricle is between the hemispheres, and the fourth ventricle sits just below the third ventricle. The choroid plexus is a special capillary network in the fourth ventricle. As blood flows through the capillaries, some of the liquid portion oozes through the capillary walls, and this becomes the CSF. Since the fluid for CSF is formed here, we must also return the fluid from the CSF to the bloodstream. The majority of this occurs through the superior sagittal sinus. The arachnoid villi are finger-like projections in the arachnoid matter, which also absorb about 15% of the CSF back into the bloodstream. The brainstem controls most of the vital functions keeping us alive. In the inferior portion is the medulla oblongata. The sensory and motor tracts will pass through here for connections between the brain and the body. There is a cardiovascular center which helps to control the heart rate and vasodilation. There is also a rhythmicity center for control of our breathing. The pons has relay stations where the messages from the neurons and tracts are passed on to the next neuron. The pons helps to control breathing. There are also nuclei where information is passed between neurons for cranial nerves 5, 6, 7, and 8. The midbrain sits superior to the pons and connects the pons to the diencephalon, as well as containing more motor and sensory connections. This area is involved with control of consciousness and sleep. You will find in the section on the nervous system there are multiple areas in the brain that do influence sleep and consciousness. There is a dark area called the substantia nigra, which is involved in Parkinson's disease. The thalamus is located in the diencephalon. This is a large relay station involved with cognition and acquisition of knowledge. This is where things become very easy or almost automatic for us, such as signing your name or driving your car. At first you had to spend a lot of time thinking about these activities when you were learning them, but now you probably recall very little about your drive between home and the places you go regularly. This is why it is helpful when you learn to listen to the information, read it, and write it. The more often you pass the information through the thalamus, the more quickly it passes through and the easier it is to recall the information. That is also why they will say not to change your answers on tests, because the information that you've actually studied is going to be more likely to transmit through the thalamus much quicker and be the first thing that comes to mind. The hypothalamus sits just below the thalamus and is involved with many different functions. This is where mental and emotional events are tied to the physical events in the body. It will control the ANS responses of the sympathetic or parasympathetic modes through control of the cardiac and smooth muscle. It controls the release of several hormones in the pituitary, giving it significant influence over the entire endocrine system. Behaviors and emotions such as rage, aggression, pleasure, sexual emotions, and pain are in this area. Hunger and thirst are also perceived here. Thirst is triggered by a change in the osmotic pressure in the cerebral spinal fluid, making it slow to detect dehydration. It helps to control body temperature by directing blood flow. When you become cold, it's going to pull blood flow in towards the core of your body. This may require you to reduce your blood volume a little bit. One thing you may notice is if you go into a cold environment, not long after going into the cold environment, you may feel the need to urinate because your body is trying to eliminate some of the blood volume. It also plays a role with wake and sleep cycles in the circadian rhythms. The pineal gland sits just below the hypothalamus and produces melatonin. This is involved with our sleep biorhythms. The presence of melatonin makes us feel sleepy and triggers the wake and sleep responses in animals. Darkness allows the production of melatonin in making us feel sleepy. Light, particularly full-spectrum UV light, inhibits the production, helping us to stay awake. There have been numerous studies done looking at people who work graveyard shifts that they are actually more productive when they have full-spectrum UV light bulbs in the building to help shut down some of the melatonin production. The cerebellum is located posterior to the brainstem. It plays a role in our balance and posture and helps to smooth and coordinate movement. It will coordinate information from the sensory receptors in the joints and tendons on movement, visual information, and equilibrium from the inner ear. The cerebellum is very easily impaired by alcohol and results in poor coordination. If you take away one of these senses that pass through there, along with impairing the cerebellum, you will find that the person will have very impaired balance, posture, and coordination. This is the whole idea behind doing the tests alongside the road when they're testing a person for drinking and driving, because the cerebellum is so easily impaired by alcohol. Every bump and groove on the cerebrum has a specific name and purpose. The gyri are the raised parts of the folds, while the sulci are the depressions in the folds. There are two halves of the cerebrum, or cerebral hemispheres, joined by a band of fibers called the corpus callosum. This allows communication between the right and left hemispheres, which is going to be important since they are slightly different in their functions. The frontal lobe is located anterior to a major depression called the central sulcus. The gyrus just anterior to the precentral gyrus, and is the primary motor area, is part of the frontal lobe. The frontal lobe is involved with initiating movement of the skeletal muscle. The parietal lobe is posterior to the central sulcus and includes the postcentral sulcus and gyri. The somatosensory area receiving sensory information from the body is in this part of the brain. The occipital lobe is on the posterior area of the cerebrum and contains the visual area. The temporal lobe is on the lateral inferior portion. The lateral portion of it is responsible for auditory sensation and equilibrium. The medial portion is responsible for olfaction or smell. On the left side, we have a couple of areas that are specialized for language. The Wernicke's area interprets spoken word. This is where we actually understand the meaning of the sounds we hear in language. Broca's area is responsible for producing sensible speech. This is where we actually choose the proper words to convey the meaning we want when talking. Both of these areas can be commonly affected by strokes and are referred to as aphasias. A person with a Wernicke's aphasia is not going to understand things that are being said to them, while a Broca's aphasia will be able to produce sound, but they don't produce logical speech. It is possible that both of these areas can be affected in stroke victims. We have 12 cranial nerves. They each have a Roman numeral assigned to them as well as a name. They are commonly abbreviated as CN, followed by the Roman numeral. Cranial nerve 1 is the olfactory nerve and connects the nose to the olfactory lobe of the brain, or the primary olfactory area. Cranial nerve 2 is the optic nerve. This will carry the message of the visual image perceived to the occipital lobe. Cranial nerve 3 is the oculomotor nerve. This is associated with eyelid movement, pupil constriction, and one of the 3 nerves involved in eyeball movement. Cranial Nerve 4 is the trochlear nerve. It is involved with eyeball movement as well as mechanoreception, or knowing where your body is in space relative to the rest of your body. For example, if you have your eyes closed and turn your eyeballs to the side, you are aware of your eyeballs turning to the side without having to open your eyes and see where they're actually facing. Cranial Nerve 5 is the trigeminal nerve. This is involved with a lot of sensation to the face. It is responsible for touch, pain, temperature, and mechanoreception. It is also involved with chewing. If you've had your mouth numb for dental work, what they're numbing is a branch of the trigeminal nerve, and you'll notice when that is numb that your chewing and eating is poorly coordinated. Cranial Nerve 6 is the abducens nerve. It is involved with eyeball movement and mechanoreception as well. Cranial Nerve 7 is the facial nerve. This will carry motor messages to most of the face. This includes facial expression, tears, and saliva production. It will have a sensory role in mechanoreception and taste. This is going to actually be the taste sensation to the anterior two-thirds of the tongue. Cranial Nerve 8 is the vestibular cochlear nerve. The cochlear portion is involved in hearing and the vestibular portion in equilibrium. Cranial Nerve 9 is the glossopharyngeal nerve. Glosso means tongue. This goes to part of the tongue and throat and is involved with taste on the posterior one-third of the tongue and the gag reflex. On the posterior one-third of the tongue is where you're going to be most sensitive to bitter flavors. In a lot of the plant world, the bitter alkaloids are poisons, and by coordinating it with the gag reflex, it helps to reduce the likelihood of us poisoning ourselves. Cranial Nerve 10 is the vagus nerve. This is the cranial nerve involved with the craniosacral control of the parasympathetics. Cranial Nerve 11 is the accessory nerve, sometimes called the spinal accessory nerve. This will control some of the head and shoulder muscles and mechanoreception to those areas. Cranial Nerve 12 is the hypoglossal nerve. It is involved in speech and swallowing, as well as mechanoreception in that area. This picture shows the location of each of the cranial nerves on the inferior surface of the brain. Here we have a quick animation of cranial nerves. Again, you'll have access to this animation either through the Tegrity system or on the Angel website. A little morbid here, but we take the scalpel and remove the scalp. So you will be able to complete this on your own.